Welcome back. Let's continue with class 12 mathematics chapter 4 determinants. Now exercise 4.2. This will be the fourth video on this exercise. Question number 12 and 13 we shall do today. Now this is a request, like we are not solving all the questions for you, okay, because that will be similar to just writing down notes from some guidebooks, isn't it? So we will be just doing some of the questions which we find, all the questions are actually the same only, so we're just randomly picking up and solving questions that might just help you to solve the other questions. So we would request you to solve the other questions, and definitely if you cannot solve the other questions, whichever questions you cannot solve, please email us or leave a comment below so that we can respond to your request. So let's see with this question number 12. Using properties of determinants, you have to prove this statement. So now we can always take a moment to look at the proof, okay, because at the proof you will see 1 minus x cubed whole square. So 1 minus x cubed whole square, so that is similar to a formula which we can do it in this way. Maybe then let's see 1 minus x cubed. So this is like, this simply depends on your practice, okay, so practice as much as you can, but we have one formula that is like 1 minus x cubed, that is similar to a cube minus b cube. Now the formula to this is 1 minus x 1 plus x square. So this is the formula for 1 minus x cube. So 1 minus x cube whole square means like double of 2 exponent. That will be similar to like 1 minus x cube whole square will be something like 1 minus x 1 plus x square whole square. So most probably we are going to need this. So from the proof, that is what we can make out. So now if we turn back to our left hand side, we can see that this value we already can achieve. That is, if we just add the respective columns. So let us do that. Then in that case, what we will do now here is in column 1, I will apply column 1 plus column 2 plus column 3. So 1 plus 2 plus 3. So 1 plus x square. Here also 1 2 3. 1 plus x square. 1 plus x square. The other two columns, let us leave it as it is. So now the moment we do that, we can take out 1 plus x square common from column 1 x square. So you can see that we already have one part of the proof, this part. So let us continue. So 1 plus x square. So now here, whenever we have this 1 1 1, it's quite simple. Maybe we can apply r2 as r2 minus r1, r3 as r3 minus r1. Again, look at the proof, 1 minus x, so 1 minus x, maybe that can also be possible. So let's see, r2 minus r1. So 1 minus 1 0, 1 minus x minus x square. R3 minus r1, 0, x square minus x, 1 minus x square. So 1 plus x square. We can do some more simplification. X square, 0, 1 minus x, if we take common, 1 minus x, 0, again x if we take common, x minus 1, just be careful with that. 1 minus x square can be 1 plus x 1 minus x, no, because we have the formula a square minus b square is a plus b into a minus b. So 1 plus x square. Now we can take 1 minus x common from row 2, 1 minus x common. Again 1 minus x common from row 3, 1 minus x. But remember, just be careful here, we have made some changes. 0 1 x, here 0. Here what happens is I've taken 1 minus x common. but this is x minus 1, so that will be what? Minus x, because x minus 1, if we take minus common, that is 1 minus x, so minus 1 will be left because I've taken 1 minus x common. Here no problem, that is 1 plus x. So now if we expand, so 1 plus x square, so you can see that we are slowly moving towards the formula, that is 1 minus x whole square. This part we already have, so we only need this whole square. So if we just expand along c1, leaving aside this two zeros, so we'll have only one value, so that will be 1 into 1 plus x minus x into minus x. So 1 plus x square, 1 minus x whole square, 1 plus x minus x square, sorry, minus plus. So you can see 1 minus x square, 1 plus x square whole square, so that will be 1 minus x, 1 plus x square whole square. So in the beginning I have already told you that this is nothing but whole square expansion of 1 minus x cubed the whole square, so this can be simply used as 1 minus x cubed the whole square. So this is our right hand side. So it's always, as I mentioned, look at the proof, what you're supposed to prove. That will always give you an idea and a hint on how to solve a particular problem. Moving ahead to question number 13. 1 plus a square minus b square twice ab twice b twice ab, 1 minus a square plus b square minus twice a minus twice b, 2a, 1 minus a square minus b square, 1 plus a square plus b square whole cube. So let us first note down the left hand side. 1 plus a square minus b square twice ab twice b twice ab, 1 minus a square plus b square minus twice a minus twice b, 2a, 1 minus a square minus b square. Now what do we have at the proof here? 1 minus a square plus b square whole cube. Okay, so how do we get this value? 1 plus a square. In almost all the terms we have almost similar terms. You see 1 plus a square, 1 plus a square, 1 plus a square. So we just have to convert this particular terms. Now that means I need plus values now. So what I can do here is I can apply one, that is column 1. If I apply column 1 minus b times of column 3, column 1 minus b times of column 3, in that case I'll just do the solution part also here. In that case I'll have 1 plus a square minus b square minus b into minus 2b, that will be 1 plus a square minus b square plus 2b square, that is 1 plus a square plus b square. So similarly I'll just do the rough here. Okay, similarly if we apply column 2 as column 2 minus a column 3, what am I trying to do here? I'm trying to get here at least 1 plus a square plus b square common in most of the terms, so that I can take that out as common. So if we apply that, column 2 twice ab minus a into, especially I'm trying to get the term from this 2. Okay, the other values will get evaluated as it is. So minus 2a minus a into 1 minus a square minus b square minus 2a minus a plus we will do with this term. Okay, so 1 plus a square plus b square minus a into 2a. Column 3. So not minus, let's do plus, then I think it will be correct. 1 minus a square plus b square plus 2a square, so 1 plus a square plus b square. So I think if we apply these two operations, I think let's see what we have. Now these are wrong, So applying these two operations, what will we have in column 1? Column 1, the first term I've already calculated, this one, 1 plus a square plus b square. What about the other terms? 2ab. So I'll just do here 2ab minus b into 2a. 2ab minus 2ab, that will be 0. And what about this? 2b minus b into 1 minus a square minus b square. So 2b minus b plus a square b plus b cube. So that will be b plus a square b plus b cube. If we take b common, 1 plus a square plus b square. So b into 1 plus a square plus b square. Okay, now column 2, the next operation, that was about this one. Column 2 plus column 3, 8 plus, so that will be 0. The other values also please calculate. You will get this values, minus a, 1 plus a square plus b square. Column 3, I'll leave it as it is, minus 2b, 2a, 1 minus a square minus b square. So now when I do this, I can take 1 plus a square plus b square common from column 1 and another common from column 2. So 1 plus a square plus b square. So what do we have here? 1, 0, b, 0, 1 minus a, minus 2b, 2a, 1 minus a square minus b square. So now let us proceed again. One plus a square plus b square whole square. Now again, here I will again apply the operation r3 as r3 minus b times of r1 plus 8r2. Sorry, I will just write it below here so that we can do the rough calculations also. Okay, so here I'll do the rough. So r3, I will apply r3 minus b times of r1. There are many other ways in which we can do this also. Okay, I'm just trying one. So that means r1 and r2 I will let it be as it is. So r1 and r2 no changes. 1 0 minus 2b, 0 1 2a. I want to reduce this. So now first one, r3, this term by term, b minus b times of r1 plus a times of r2. So that will be b minus b plus 0, that will be 0. Similarly, next term, minus a minus b times of r1, 0, plus a times of r2, 1, minus a plus a, that is again 0, and here you will have 1 plus a square plus b square. So now after this, 1 plus a square plus b square whole square, if we just expand along column 1, so that will be 1 into 1 plus a square plus b square minus 0 into 2a. So that will leave us with 1 plus a square plus b square, 1 plus a square plus b square minus 0, that is alright, no problem, whole square. So we have our proof, 1 plus a square plus b square whole cube. So this is slightly tougher question, but you can always do it with practice. So there are many other steps, many other operations which we can apply. This is just one that I have tried on the spot here. So maybe you can try some other ways also, no problem. These are all about practice, hit and trial method. So you can keep on practicing. You may come across different methods to solve this problem, maybe more simpler than what I have done here, definitely. So please stay at home, stay safe, and see to it that your syllabus is taken care of when you're sitting at home from all the help that you can get. Thank you. Have a good day.